Something strange happens when you try to look inside an atom, and Richard Feynman loved that strangeness, not because it was mysterious in the lazy sense, but because it was precise in the most unsettling way. Because the moment you stop imagining atoms as tiny solar systems or neat colored balls in a textbook, and instead ask what it really means to look, to observe, to measure, the entire idea of reality begins to loosen its grip, as if the universe itself clears its throat and says, "You have been asking the wrong question." Because to look inside an atom is not like opening a box or peeling an orange. There is no inside the way your intuition demands, no tiny room where electrons politely orbit a nucleus waiting to be seen. Because the act of looking is not passive, it is violent in a subtle way. It requires interaction, and interaction at that scale means disturbance. It means you cannot observe without participating. And the atom knows this, or rather obeys this, because nature is not hiding. It is behaving exactly according to rules that do not care about your comfort. So when you try to see where an electron is, you must hit it with something. Light, perhaps. But light is not a gentle flashlight at that scale. It is a punch, a collision, a shove. And the electron responds, not by revealing its position, but by changing it. And this is not a flaw in our instruments, or a temporary limitation waiting for better technology. This is built into the structure of the universe, which Feynman found endlessly hilarious and terrifying at the same time. Because it means the universe is not a stage where objects exist independently and we merely peek in from the audience, but a dance floor where observation itself changes the choreography. And this is where things get truly strange, because before you look, the electron is not hiding somewhere definite. It is not secretly somewhere you just haven't found yet. It exists as a cloud of possibilities, a mathematical statement about where it could be. And the math is not a metaphor, it is the thing itself. The equation does not describe reality, it is reality. And when you look, when you force the question, the universe is compelled to answer in a specific way, collapsing possibility into fact. And Feynman would grin at this because it sounds mystical, but it is brutally practical. It works. It predicts numbers to absurd accuracy, and yet it refuses to make intuitive sense, because intuition evolved to throw rocks and chase food, not to understand atoms. And here is where Feynman would warn you not to demand understanding in the childish sense, not to ask for a picture you can hold in your head like a toy model, because nature does not owe you that. And the deeper you go, the more your everyday ideas of position, motion, cause, and effect start to melt, because inside an atom, particles behave like waves, and waves behave like particles, and neither description is fully correct on its own. And the electron does not travel from point A to point B along a path the way a marble rolls. It explores all possible paths simultaneously, sniffing out every option like a quantum bloodhound. And somehow, when you add them all up, the correct outcome emerges, not because the electron shows wisely, but because the mathematics of probability amplitudes interfere, reinforcing some possibilities and canceling others. And this is not poetry, this is calculation. This is how transistors work, how lasers work, how the device you are reading this on exists at all. And yet, if you stop and really think about it, the idea is insane, because it means reality at its foundation is not made of things, but of tendencies, not certainties, but likelihoods. And Feynman would emphasize that this is not a philosophical choice, it is an experimental fact, verified again and again. And the strangest part is not that atoms are weird, but that the world you experience is stable at all, because trillions upon trillions of these probabilistic events average out into the illusion of solidity. So your chair feels solid, not because it is solid in a classical sense, but because the electromagnetic forces between atoms are so strong and so precisely balanced that they prevent collapse, creating a macroscopic lie that is good enough for survival. And when you try to look inside an atom, you are tearing a hole in that lie, peeking behind the curtain to see that matter is mostly empty space, structured by forces and rules that do not resemble the objects they create. And Feynman would point out that even the word inside is misleading, because the atom is not a container. It has no edge the way a box does. The electron cloud fades outward infinitely, never quite ending, meaning that in a very real sense, atoms overlap. You are sitting inside the atoms of the chair, and the chair is sitting inside you. But the forces cancel in such a way that you don't fall through.
And this overlap is not metaphorical, it is literal, according to the equations. And once you accept that, everyday language begins to crack, because what does it mean to say something is here or there when location itself is fuzzy, when position is defined only upon interaction? And this leads to the most unsettling realization of all, which Feynman often circled without sentimentalizing, that reality is not made of answers, but of questions, not fixed properties, but measurable interactions, and the universe does not carry a list of facts waiting to be revealed, it carries rules for how outcomes are generated when you ask, and the atom does not contain a secret movie of what it is doing when you are not looking, because doing is the wrong verb, it is existing in a superposition of potentialities governed by a wave function that evolves smoothly until you intervene, and then, abruptly, yet statistically lawfully, it snaps into a result. And this snap is not explained by anything deeper we know. It is simply how nature behaves, and anyone who tells you they truly understand it is either lying or confused. And Feynman would laugh and say that the correct response is not despair, but delight, because the universe is under no obligation to be simple, and the fact that we can write equations that predict atomic behavior to 12 decimal places while having no comforting picture of what is really happening is one of the greatest achievements of the human mind. And when you try to look inside an atom and feel your intuition fail, that failure is not a weakness. It is a signal that you have reached the boundary where everyday thinking stops being useful. And beyond that boundary is not chaos, but a deeper, stranger order, one that does not care about how things seem, only about how they calculate. And in that sense, the atom is not strange at all. It is perfectly consistent. It is we who are strange for expecting the universe to be built out of concepts that fit neatly inside our skulls. And so the final twist, the thing Feynman wanted you to feel in your bones, is that when you look inside an atom, you are not uncovering the smallest pieces of reality. You are uncovering the limits of human imagination. And the atom does not reveal itself as a thing, but as a lesson that the universe is far richer, far weirder, and far more precise than any story we can comfortably tell about it.